Okay, in this video we're getting some practice with implicit differentiation. The y is implicitly defined as a function of x from the following equation, from this equation right here. Log base 2 of x squared y squared is equal to 4. This defines y as a function of x, not directly but implicitly. Okay, and we are ultimately going to try to find what is the second derivative of y with respect to x. This is the symbol that means the second derivative. The second derivative of y with respect to x. Derivative. Okay, so to work, you could work with this equation just as it is. You could use your knowledge of the derivatives of logs, and you'd end up with something like 1 over the natural log of 2 times x squared y squared, and then start taking the chain rule. You could do that, but I think it makes it much easier and much cleaner if you remember how to write a logarithm in its exponential form. This means implies. It works both ways. So let's see here. What I'm going to do is since this is a log base 2, I'm going to take 2 and I'm going to raise 2 to both sides of this equation. So 2 raised to the log base 2 of x squared y squared has to be the same as 2 raised to the right hand side, 2 to the 4. Now 2 raised to the log base 2 of x squared y squared is just x squared y squared, so that's nice. And 2 to the raised to the 4 is 16, right? 2 times 2 is 4 times 2 is 8 times 2 is 16. Okay, good. Let's make sure that this is recognizably a 2. Yes, that's a 2. Alright, so we have x squared y squared equals 16. Let's do our implicit differentiation on this. Now the goal is to get the second derivative, but first I'll have to find the first derivative, okay? Because the second derivative is nothing other than the derivative of that first derivative. So here I go, trying to find the first derivative. Alright, well, first of all, look on the left-hand side here. This is actually a product of two things. It's a product of x squared times y squared. So I'm going to have to use the product rule here. We're going to use the chain rule quite often, but to begin with, we're going to have to use the product rule because I have these two things multiplied together. So x squared, the derivative of x squared is 2x to the first power. So 2x times, leave the y squared alone, right? Now plus, because I'm using the product rule, we'll leave the x squared alone and take the derivative of y squared. Now the derivative of y squared is 2y to the first power, but now I have to use the chain rule since y is actually a function of x, so times the derivative of y. On the right hand side, we're taking the derivative of 16. 16 is a constant, so constants don't change, and therefore the derivative is 0. Okay, so far so good. Let's try to isolate this y prime so we know what the first derivative is. Give myself a little more room here. Alright, so I'm trying to isolate this y prime. This is what we're trying to get by itself. And so I'm going to move the 2x times y squared to the left hand side by subtracting. So we're subtracting 2x y squared from both sides. By the way, it's usually the case if you need to move something to another side, usually you do that by adding or subtracting. You usually don't move things to the other side by dividing or multiplying. Okay, so we're going to subtract to move it to the other side. So we end up with x squared times 2y times this first derivative is equal to negative 2xy squared. Remember, we're trying to isolate this y prime. Now's the time when we can go ahead and divide. So we're going to go ahead and divide both sides. I'm going to divide both sides by 2x squared y. Right? Dividing both sides by 2x squared y, that will get rid of everything I don't want on the left-hand side. So I have 2x squared y over there as well. Alright, so these all cancel out. Some of this stuff cancels out, and we're left with y prime is equal to negative 2x y squared over 2x squared y. And of course this, quite a bit of this cancels out as well. In fact, so these 2's will go. We can get rid of one of the x's from the top and one of the x's from the bottom. Here I can get rid of one of the y's from the bottom and one of the y's from the top, and we're left with negative y over x. Make sure you look at that carefully, do the cancellations yourself, so that you can be confident that the first derivative is negative y over x. Now if we had a point on the curve defined by that implicit function, we could plug the coordinates of that point in and we could actually have a value for the first derivative. So just write it down nicely in one place. The first derivative is negative y over x, and I will certainly be using this as we go. Now the goal is actually to find the second derivative, but there is the first derivative. If you want to find the second derivative, it's great to find the first derivative, because now we just take the derivative of this. Okay, here's another way of writing y prime that may be a little more useful for finding the derivative. So y prime is negative y times x to the negative 1, right? X to the negative 1 means 1 over x, so it's negative y times 1 over x. It's exactly what we have right here. I'm just saying that these two are the same thing written in different ways. And now I'm going to take the derivative of both sides to get the second derivative. So the derivative of the first derivative is the second derivative. That's pretty easy. And now let's now here again we have the product of two things. So again, I'm going to have to on this I'll have to use the product rule, because I'm multiplying negative y and x to the negative 1, right? So the derivative of negative y, that's like negative 1 times y. So that's just negative 1 times y prime. So this is negative 1 y prime there. And that's going to be times x to the negative 1, leaving it alone. That's the way the product rule works. Plus, now we'll leave the negative y alone and take the derivative of x to the negative 1. The derivative of x to the negative 1 is negative x to the negative 2. Alright, maybe we can clean this up a little bit now. This is actually negative y prime over x, and then I'm going to have this negative times that negative becomes positive, so it's plus negative y over x squared. Okay, this is very good. Right now the main problem I see is that we don't have a common denominator, so we couldn't combine anything anymore. So to get a common denominator, I'll multiply both sides of this term by, or the top and the bottom of this term, by x over x, right? So that there'll be a x squared in the denominator. So down below now I have negative y prime, the negative of the first derivative, times x over x squared plus negative y over, oh, should this be a, one thing I just noticed, should this be a negative y? I'm going to go back and check on that. See, this was a negative times a negative. Right there is a negative, and right there is a negative. Those two negatives actually cancel each other out. So this should actually be a positive here. Yeah, this should be a positive. I'm glad I caught that mistake. Alright, so this is positive y over x squared. Now we have common denominator, so we can combine the top. I'm going to write it like this to begin with. This is negative y prime x plus y over x squared. This looks pretty good. Instead of having a negative y prime x, how about if we write this as y minus y prime x, yep, over x squared. Alright, now we've come to a point where there's not a lot more simplifying that can be done as long as we just leave this y prime alone. You see, in finding the second derivative, which is what this is, we have this first derivative here. But we know what that first derivative is because we already found it. We found that the first derivative was negative y over x, right? So I think this is now a good time to plug that in. In other words, we found the first derivative already. We found the first derivative, it's right here, and in finding the second derivative, which is what we've been doing, this whole thing is the second derivative. Whenever you find the second derivative, you may end up with terms in it that involve the first derivative, but we know what it is, so let's just do the substitution. So I'm going to go ahead and do this substitution now. This is the second derivative is equal to y minus, now we know what the first derivative is, it's negative y. It's negative y over x, and then this is times x. You see, this x here is the same as this x there. And this whole thing is over x squared. We can do some simplifying now. Negative y over x times x just becomes negative y. So we now have y double prime, that is the second derivative, is y minus negative y over x squared. Okay, the reason for that is because this x and that x canceled out. And now we have, we can go, we're subtracting a negative, so this is really like adding, so this is y double prime is y plus y over x squared, which becomes 2y over x squared. Alright, I think that's probably the nicest form of the second derivative we can hope for. So we'll write down our final answer here. We have y double prime is d squared y over dx squared, which is 2y over x squared.